Hey guys, we're starting chapter 7 in geometry. So today our section is on ratios and proportions. So in the past, we have wrote and solve equations. Today we're going to work on writing ratios and writing and solving proportions. So a lot of algebra in today's lesson. Okay, so some new vocabulary. Hopefully we've heard these words and used them before. We have a ratio, which is a comparison of two quantities by division. We have extended ratios, which are used to compare three or more quantities, and we'll use those in a couple examples. We have a proportion, which is setting two ratios equal to each other, and cross products. So if we have A over B, and that's equal to C over D, then the product of A and D is equal to the product of C and B, and we'll use that as well. Okay, so here's a real-world example. We're talking about students in schools. So the number of students who participate in the sports programs at Central High School is 520. The total number of students in the school is 1850. So we have to find the athlete to student ratio to the nearest tenth. So what we'll do is we'll take the part over the whole. So our part is this 520 students over the whole, which is this 1850. And when we divide those two numbers, we'll get that ratio to the nearest tenth. So we'll set them up here. So we have the number of athletes, like I said. And then when we divide those out, we get about 0.3. So our ratio of athletes to students is 0.3. Okay? All right, here's another one for you guys to try. Pause your videos for a second and do some math on the side piece of paper. Okay, so the country with the longest school year is China, and they have about 251 days. We have to find the ratio of school days to total days in a year for China to the nearest tenth. So we're using that 365 days out of the year. We're forgetting about leap year, okay? And we'll set it up as 251 over 365, so that's the part, this is our whole. When we calculate that out, we get about 0.7, okay? So now here we're using extended ratios. So we're given a triangle EFG, so I'll just sketch that over here. So E is here, F is here, and G is here. Okay, and it says the ratio of the measures of the angles is 5 to 12 to 13. Now this is that extended ratio that we talked about in the vocabulary where we have three or more things that we're comparing. So I'm just going to fill in these angles. So we have 5 here, 12 here, and 13 here. Now these numbers don't necessarily mean 5 and 12 and 13 degrees, that's just the ratio. So what we would have to do is take 5x, because it's simplified, so we're multiplying something by this 5, plus 12x plus 13x, and we're going to set these equal to 180 because that's the sum of the interior angles of a triangle. Okay, and then actually I'm just going to use this. Okay, so that's talking about what I was talking about. There we go. All right, it's going to combine our like terms, so we get 30x equals 180. When we divide that 30 over, we get x equals 6. Now we're not quite done because we want to find what the measures of the triangle are. So we plug that 6 back in for 5x, 12x, and 13x. So the measures of our triangle angles are 30, 72, and 78. Okay, here's one for you guys to try, all right? So another triangle, we have triangle ABC, and now the ratios of the angles are 3, 5, and 7. So pause your video for a second and figure out what the measure of the angles are. Okay, so if we do this just like we did the other problem, we should have 3x plus 5x plus 7, oops, I don't know, 17, 7x equals 180. Okay, so we get 3, 5, and 7. That should give us 15x equals 180. When we divide that out, 180. Divide that out, we should get 12. Does that seem about right? Yeah. So when we plug 12 back in for these with that x value, we'll get 36, 30, and 84. All right, so here's the cross products property. You guys probably use this a lot in Algebra 1, maybe Algebra 2 as well. So it's saying in a proportion, the product of the extremes equals the products of the means. Okay, so what we're talking about is if we have A over B equals C over D, like we talked about in the vocabulary. Now if B is not equal to 0 and D is not equal to 0, then the product of A and D is equal to the product of B and C. So in this example over here, I don't know if you can see it or not, hopefully. So we have 4 over 10 equals 6 over 15. So if we take like the butterflies, maybe you guys call them, the crisscrossies, right? So if we take the product of 4 and 15, that'll be equal to the product of 6 and 10. So let's apply that now. Okay, so over here we're solving for y. So if we use this cross product, we should have 18.2 times 9 equals 6 times y. So we apply this cross products property. This side we're going to have to simplify out and divide by 6. So now we get y equals 27.3. Now if we wanted to check, we could put 27.3 there. We could see if 6 divided by this 18.2 was equal to 9 divided by that, or we could take the cross products. There's multiple ways that we could check our work to see if we got the right answer. Okay, so here's another one. This one's a little bit different because now we're given an expression rather than just a number. So we're going to apply the cross products property. Now I really want to stress use parentheses, because what we're doing with this 6 is we're distributing it to this entire expression, not just the 4x, not just the -5. We need to put that into each of those values. So we have our parentheses here with what we're substituting in. We're simplifying. Okay, now we're just solving for x, so we'll add 30 to each side. Okay, now we're dividing by 24, so we get x equals -2. And that's our answer. Okay, here's one for you guys to try. Pause your video, do a little bit of math. Okay, so the way that we should set this up is we would take those cross products. We should have 13.5 times 14. There should be a point in here. Equals 42b. No, I can't really do that in my head. So if I take 13.5 times 14, we get 189 equals 42b. Now we need to divide that 189 by 42. We get 4.5. So our answer should be B. B equals 4.5. Okay, here's another one. Remember, use your parentheses when you're setting this up, so pause your video, go ahead and do this. So when we set it up, I'm going to put 7n minus 1 in the parentheses, and I'm distributing a 2 through it because that's that cross. Okay, and that will be equal to 8 times 15.5, which is that cross. Okay, when we go through, on this side, we're distributing this 2 through, so we get 14n minus 2 equals 8 times 15.5 gives us 124. Okay, add the 2 to both sides, so we get 14n equals 126. 126 divided by 14 gives us 9. So our answer should be A, n equals 9. Okay? All right, I think this is our last example that we're going to work through. Okay, so Monique randomly surveyed 30 students from her class and found that 18 of them had a dog or a cat for a pet. If there are 870 students in Monique's school, predict the total number of students with a dog or a cat. Okay, there's multiple ways that we can set this up, but I'm going to give you one. So I like to do part over whole. So in this first sentence, there was a total of 30 students that she surveyed, and 18 of them had a dog or a cat as a pet. So I'm going to say 18 is part of that whole. Okay, and that we're setting up a proportion now, so we have part over whole. We need to have it equal to part over whole. Now what we're trying to find is how many students in the entire school would have a cat or a dog. So I would say x over 870, because this 870 is the total amount of students in her school. X is what we're trying to find, it's that part. So, maybe it'll set it up for us. Yes. Okay? So we go ahead, we apply the cross products property, so we take our one crossy equal to our other crossy. All right, we're going to simplify on this side, divide by 30 to find x. So our answer is that there should be, if we were predicting, about 522 students out of that 870 students who would have a pet that's a cat or a dog. Okay. All right, here's one for you to try. It's the same kind of situation, but now we're talking about jobs. So Brittany randomly surveyed 50 students and found that 20 of them had a part-time job. So my eyeballs are automatically saying that I have a part over a whole. So I see 20 is part out of a whole that's 50, and I know that's going to be equal to some other proportion or ratio. So it says if there are 810 students in Brittany's school, predict the total number of students with a part-time job. Well, I know that there's a total of 810, so I want to know what's up here, so I'm going to put x. Now to solve this, I'll apply the cross product. So I have 20 times 810 equals 50x. Just do this. I shouldn't even need that. So I get 16,200 equals 50x. Now when I divide by 50, I get x equals 324. So now that answer is saying that about 324 out of the total 810 students is our prediction of how many have a part-time job. Okay, now this is just, remember I said there's multiple ways to set up these proportions. This is talking about all the different ways that you can set it up. There's no one correct way to set it up, but there are incorrect ways, if that makes sense. So notice that in all of these, our A and D are on opposite sides. Okay? So as long as A and D are on opposite sides, and one's on the numerator, one's on the denominator, we're still finding the product of those two. Now our C and B, notice, are also on opposite sides. So no matter what, all four ways that these are being set up, we're still finding the product of A and D, or D and A, same thing. And we're setting it equal to the product of B and C, or C and B, which are all the same. So here they have an example using some numbers. If you were to go out and apply the cross product property to these, you would get the same exact value for x no matter how you set it up in this way. So our assignment today is page 464. We're going to do 11 through 39 odd. As always, let us know if you have any questions, and best of luck on it.